Hello and welcome to this Revision Monkey video on the required practicals that are going to be in the 2022 Physics Paper 2 exam. This is for the AQA specification and it's for combined scientists, and that's the trilogy version of combined science, which means you take 6 exams at the end of your course, all of which are 1 hour and 15 minutes long. And this video is for the higher tier students. The practical that they've asked you to focus on is infrared radiation, so that will be covered in this video. And do keep a lookout in the description because I'll put a link there to the key content you need to know for this exam, and also a link to some practice questions to help you with this required practical.
Infrared radiation required practical. There's 2 practicals that we could look at for infrared radiation. The first one is to do with emitting infrared radiation, and the second one is to do with absorbing infrared radiation. So in this first practical, we'd place a Leslie's cube on a heat-proof mat and fill it with boiling water from the kettle. Now the Leslie's cube is just a metal cube with different coloured surfaces on the vertical sides. So for example, you could have a white surface like this, you could have a matte black surface, a shiny black surface, and a silver surface, for example. Using a ruler, we would measure a set distance, so I've just suggested 15 centimetres, from one side of the Leslie's cube and place an infrared thermometer here facing the cube. We'd repeat for the other 3 faces, making sure that the thermometer is always 15 centimetres away from the cube. This will detect the amount of infrared radiation that is emitted by each side of the Leslie's cube. You would then repeat the experiment 3 times and calculate a mean for each side. The surfaces such as matte black, which are really good emitters of infrared radiation, should give you really high readings of infrared radiation coming off of the Leslie's cube, whereas surfaces such as white and silver, which are poor emitters, will have lower readings. Alternatively, you could be asked about the absorption of infrared radiation instead of emission. And in this practical, you would stick something metal like a coin to different surfaces, for example black paper and white paper, using wax. You would then put the surfaces equal distance from a Bunsen burner, so you'd measure with a ruler to make sure that they were exactly the same distance away, and this would be our control variable, the distance between the Bunsen burner and the material. And you would time how long it takes for the coins to fall. And then you'd repeat the experiment 3 times and calculate a mean. So the materials that are better at absorbing infrared radiation, like matte black, it is not only a good emitter of radiation, but if you are a good emitter, you are also a good absorber. So this material should absorb the infrared radiation that's coming from the Bunsen burner a lot quicker, causing the wax to melt and the coin to drop quicker than, for example, a white surface.